Hello and welcome to Cambridge O-Level Physics paper number 1, multiple choice. This is October-November 2020 paper. The code for this exam is 5054 and this is version number 1 of this paper. So let's start. First question, it says a heavy nail is fixed firmly to the wall. It is pulled by a string at 40 degrees to the vertical. The nail does not move. The three forces act on the nail. Number one, it's the weight of the nail, W, it's the tension in the spring T, and the force R exerted by the wall. Which diagram drawn to the scale represent the three forces? So this is how the we have. So this is the nail. This is the pull on the string. So the tension would be something like this. Weight of the nail will act downward. So the weight of the string will act downward and it will be given by W. So my W will look something like this if I extend it back, and the reaction force or the force exerted by the wall will be given as this. So this will be the shape of my triangle. I name it as A, B, and C. Anything that looks similar to this will be our shape. Also remember the parallelogram law or the rule. So this will be equivalent W and this will be equivalent R. So anything either A, B, C or A, D, B, any shape that corresponds to this will be our answer. So let's check. So A is tension in this manner, tension in this manner. So this is my AB, weight downwards. So this is something like BD and R is in the X direction. So A basically checks our case. So then part B, we have tension in this direction. So no, weight acting downwards, R in the other direction. So no, this is not something we are looking for. Again, part C, tension is in this direction. Yes. Weight downwards. Yes. R is in this direction. No, our R is in this direction. So the direction of R is not to up. Case part D, tension is in this direction. So now again, this is not the case. So answer A is the best choice we have. So next question, question number 2, it says a car begins to move. It speeds up until it reaches a constant speed. It continues its travel at this constant speed for the rest of its journey. What happens to the acceleration and what happens to the velocity of the car during the journey? So first of all, we know that the car begins to move. It means that initially it might be at rest and it starts to move till the time it reaches constant speed and it stays there. So technically what happened, initially the speed changes, basically the velocity changes, and in a way the car accelerated till it reached constant speed. So so our acceleration has changed, our velocity has changed. So what happens to velocity and acceleration? So basically both acceleration and velocity change. Yes. Only acceleration changes. Yes, it's partially true. Only velocity changes. It's again partially true. Neither acceleration nor velocity changes. No. So the best answer is A. Next question. Question number 3 states that a car of mass 800 kg has forward acceleration of 2.5 meters per second square. So we are given a mass, let's call it m equals to 800. Acceleration, let's call it a as 2.5 meters per second square. Frictional force of 200 or 1200 newtons. So we call it F with the subscript F equals to 1200 newtons. Opposes the motion of the car. What is the driving force due to engine of the car? So let's find out. Let's see how it looks like. So say this is our surface. And this is our car. So this is our car. And this is moving in this direction. So this moving in direction, so force equals to, we have to find out the force by the engine. So mass is 800 kg and it is accelerating at 2.5 meters per second square. So technically, a force is acting in this direction. This is MA, and multiplying 800 by 2.5, we get 200. Sorry, 2000 newtons. And the frictional force is acting in this direction. This is FF, and this is 1200 Newton. So what is the force that is being exerted or by the engine in order to drive the car? So this force is basically what that is accelerating, and plus it is overcoming this friction as well. So you have to add this friction up as well. So overall force is 3200 Newton because the car is accelerating and the mass is 800 Newton. So the effective equivalent force that is acting on the car is this forward force. You can call it F forward as well. And the friction force is 1200 Newton, and that is being compensated by the force developed by the engine. And then we have to add this. Engine actually needs to produce overall 3200 Newton of force in order to compensate the friction and generate this force. So our actual value is this. So remember, the normal error students make over here is that they get this vector as 2000 Newton and reverse force as 1200 Newton. So what they do is 2000 minus 1200, they get 800 and go with this. So this is not the right answer. So please do not make this mistake in your exam. Okay. So next question. Question number 4. A parachutist falling at steady speed opens her parachute. Which row is correct for the direction of the resultant force and the direction of the acceleration of the parachute just after the parachute opens? Okay, so remember, so a parachute, it will look something like this. So at just the point the parachute opens, the person is falling down, and the parachute opens, it basically moves up and then starts falling back. So the resultant direction will be just at the instant he opens the parachute, a resultant force acts upwards and the body is pulled upwards. So the resultant force direction is upwards and the acceleration direction. So initially the force is upwards, so the acceleration initially is at upwards until after a moment or a brief moment it starts, it comes to zero, and then the person starts falling back to the ground under the action of gravitational force, or you can say that as soon as it reaches the terminal velocity, it's perfectly goes to zero, and the person goes or the person is pulled towards the earth. So initially, just after the parachute opens, the acceleration direction is upward. Force is upward. It means the acceleration is also upwards. So this. So both are upwards. So downwards, downwards, no, downwards, no, upwards, yes, downwards, no, both upwards. So this is the answer that best suits our case. Next question. So question 5, it says some gas trapped in a cylinder is compressed at a constant temperature by a piston. Which property of gas does not change? So remember the law PV equals to nRT. So the pressure of the gas can change, the volume of the gas can change, the temperature of the gas can change, but overall the mass of the gas won't change. So the mass of the gas will not change, the pressure may change, the volume may change, even the density is related to mass per unit volume. So volume is changing, mass is remaining constant, so density may change. So again, mass is the constant, a value that which remains constant, does not change, rest everything will change, can change. So this is the best answer we have. Then question number 6, it says a block is hung on a spring balance. The marker inside the balance is pulled down by the block. Question is, what can the piston on the what can the position of the marker be used to determine? Again, so this is the case. So this is again a spring balance. So spring balance determines the mass of the block. So it is determining the mass of the block, and mass, the units of mass are in kg or grams, right? These are the units. So again, spring balance, this balance is determining the mass of the block. So mass of the block in kg, yes, it can be an answer. Mass of the block in Newton, no. Moment caused, no. Weight of the block in kg, no. So weight, if it determines the weight, weight is always in form of Newton. So again, it's not Newton, so it can't be this, the correct answer. So the best option we have is this. Again, it can determine mass, it can also determine weight as well. And weight is in Newtons. So in either way, either this can be the right answer or this and the right answer if the units are given correctly. So next question, question 7 is an electrically charged plastic ball is at rest. What type of fields are caused by the ball? Remember, uh, say if this is a ball, this is charged, so we call it a positively charged. So electric fields are uh, caused by this ball. So electric fields are caused by this ball. And this charge is a mass, or charge is a mass, consists of some mass. So any massive object will exert some sort of gravitational force. And since this is positively charged or any singularly charged ball, it is stationary, it is not moving. So a stationary charge doesn't produce any magnetic field. So it must be moving in order to produce a magnetic field. So electric field, E field, yes. Gravitational field, yes. Magnetic field, no. So the answer will be electric field and gravitational field only, B. So B will be our right answer. Question 8. Which statement about mass and weight is correct? So let's see. Mass is a scientific term that means the same as weight. No. Mass is m, and it's a intrinsic quantity of an object, whereas weight is mg, mass multiplied by the gravitational constant. Oh, sorry, acceleration due to gravity. Then the mass of the object is 10 times on Earth is 10 times of its weight. No, again, this is not the answer. Weight is a scalar quantity. No, weight is a vector quantity. So again, this is fine. Mass is a scalar quantity. No. So vector weight is the force of gravity pull on the mass. Yes, W equals to mg. So answer D is the right choice. Next question, question 9. Which expression is used to calculate density? Remember density or rho equals to mass per unit volume. Mass multiplied by volume, mass over volume. So B is the right answer for that. Okay, it's pretty simple. Next question, question number 10. It says that the length of thread is attached to a lamina at point P as shown in the diagram. So we have this diagram. So this is point, sorry, P is the point of lamina. Force is this direction. Then we have a point Q. This, so the lamina is free to rotate about point Q. So this point can rotate about this point. So this is you can say a point or a fixed point, or a point across which moments can be taken. Moments can be taken across Q. Okay, the tension in the thread is F. So this is the tension in the thread. That what is the moment F about Q? So what is the moment F? So moment, remember, is always calculated as force multiplied by perpendicular. Oh, sorry. This is, let me have it. Oh. So it is force multiplied by the perpendicular distance from the point where moment is taken. Is to be measured. Okay, so we are going to measure moment across Q. So The overall value, the force or this moment will be distance y multiplied by the force F. So moment will be force F multiplied by this perpendicular distance is y. So Fy units will remember Newton meter. These will be units. So which one is looks the best? Fy is this. So answer number C will be our best choice. Next question. Question 11 says which list contains only quantities that can be changed by force. So remember, mass can be changed by force. No, the mass is an intrinsic quantity that can't be changed. So mass can't be changed. Again, mass can't be changed. Mass can't be changed. So this remains the last option. So velocity can be changed by the force. Yes, force changes the with the help with the application of force. We can change acceleration, and if we can change acceleration, we can change the velocity. Then yes, volume, gas PV equals to nRT. By application extra pressure, extra load, we can change the volume. And shape, yes, gases can be compressed to liquid form with the application of force. So answer D is the right choice. Remember, mass can't be changed with the application of force. Then question number 12, an extension load graph is plotted for a spring. Which point marks the limit of proportionality of the spring? So limit of proportionality. So again, it must be the point where the graph stops being linear. So if we extrapolate this thing, it comes to be something like this. So at around point B, it missed or it doesn't remain linear. So that is the maximum point till where the graph or where the limit of proportionality was observed. Or if we can see between A and B, the graph is a straight line or linear. Between B, C, there is some curve, and C, D, again, the curve is there. So B is the point which marks the limit of proportionality of the spring. Okay. So next question 13 says a mercury manometer is used to measure the pressure of a gas. The pressure of the atmosphere is P naught and the density of mercury is rho. What is the pressure of the gas? So remember, this is the atmosphere. This is the atmosphere here, and the atmospheric pressure, sorry, P naught is acting in this direction. So the pressure over here will be the because of the atmosphere. And remember, this height is H, and the pressure exerted, or this the pressure because of this height is rho, the density, G, acceleration due to gravity, and the height of this. So this pressure and this. So technically, we have to minus P naught, atmospheric pressure, minus rho GH will be equal to pressure of gas. This let's see which is the best representation of this. So part A, P naught minus rho H rho G. Yes, it looks fine. No plus, no P naught, no. So answer A will be the best option for that. So next question, question number 14. It says that there is a current in a resistor. Okay, what is the energy transfer that takes place? Remember, say this is the symbol of an resistor. The current, the current, say I is flowing in it. So when current flows in a resistor, there's this heat that is produces, and that heat is I square R. And for time t, if you want to multiply it by time t, so just generally heat produced I square R loss under the heating loss. So energy transfer from electrical energy, because of the flow of current, electrical energy is changed to heat energy, and heat energy is basically absorbed internally by the materials of the resistor. Say, for example, we have this as a actual or a practical looking resistor, actual shape, something like this. Rho equals to rho length per unit area. That will be the material. This is the area, and this is the length of the resistor. So actually it heats up internally. So electrical energy is converted into the internal energy or the heat energy of the resistor. So B answer will be the best one. Question number 15. It says a ball is dropped from a height as shown, ignoring the effects of air resistance. Which statement about total energy of the ball is correct? So before going to the statements, let's see what happens here. So at this point, say the graph, the ball will have, say this is height h, will have only potential energy. So potential energy will be mass m g h, mass into gravity into height. At this point, the energy will be potential energy plus kinetic energy. And at this point, just before hitting the surface, the ball will have maximum kinetic energy. And that is value is half mv square. So the point is the total law of conservation of energy, the total energy will remain the same. So at this point, the maximum energy is this, the overall energy will remain the same. So this is complete potential energy converts to complete kinetic energy. At this point, say we have half of potential energy, or half of the total energy is in the form of kinetic energy. So let's see. So about total energy, it is same at all the points. The total energy, remember, it's the same. Yes, same. It is greatest at point one. No, it's maximum at point one, and again, just before hitting, it will have the maximum kinetic energy. Again, at greatest at point two, no. Greatest at point three, no. It says it remains same for all points. So answer A will be the best choice, as I have shown to you. Next question, question 16. It says that which source of electrical energy is not renewable? Solar cells, it's a renewable. Hydroelectric generator, it's renewable. Wind energy, it's renewable. Nuclear reactors, no, it's not renewable energy source. So part number D, it's not renewable. Next, the table, question 17. The table shows some data from high jump competition. Which athlete jumps the highest? So say if an athlete is running from here and a high jump, he jumps over it and falls down. So the maximum energy would be at this point. So this point, the energy will be in the form of potential energy, and this potential energy can be calculated by, this potential energy can be calculated as mgh. So mgh weight is given, or this weight is also equal to mass into gravity. So this potential energy can be written as weight into height. Okay, so we can say that the increase in gravitational potential energy. So the person is initially on the ground and running. The increase in potential energy, and that is actually the complete potential energy of the person. So we can estimate height from here. So this is equal to mgh, and mg value is given 600. So height can be found out by 1320 divided by 600. Similarly, for this case, 1610 divided by 700. This case, 1760 divided by 800, and this case 1800 divided by 900. So if we find out the heights, this height is around 2.2 meters. This value comes out to be 2.3 meters. This value again 2.2 meters, and this is 2 meters. So the maximum height, or the maximum, or the jump highest, is by the athlete at B. Okay, this is how we solve this question. So next question, question number 18. It says a workman rolls a barrel of weight 2000 Newton up a plank of length 2 meter and onto a lorry. The back of the lorry is 8.08 meters high above the horizontal surface of the road. What is the work done on the barrel against the gravity? So basically, the work done is stored in the form of energy. So the potential energy at this point is given as mgh. So mass into gravity, or the weight of the barrel, is given to us. So w equals to mg. This is given to us as 2000 newtons. we just have to multiply it with this vertical height. So we multiply it by 0.8, it becomes mgh, that is equal to potential energy, and potential energy is given as 1600 Newton. Joules, not Newton, joules. So 1600 joules. So answer B is the right answer for this question. Next question. Question 19. It says data for 3 types of generators are shown. So there is an oil generator, there is a nuclear generator, there's a hydroelectric generator. So again, which is the least efficient generator and which is the most efficient? So if I have to find out, or we have to find out efficiency here. So efficiency is uh, power output by power input into 100. This is how we calculate the efficiency. So that, or we can call it energy output or energy input, right? So we are given input energy, we are given this input energy, yes. So energy output is basically energy input plus energy wasted. Okay, so if we have X amount of energy that is wasted, and if we add it into the input side, that will be, oh sorry, energy output would be energy input minus energy wasted. That will be our output energy. So in this case, our output energy is 500 minus 300, 200 divided by input energy 500 into 100. This will be our efficiency. Again, for this case, 200 minus 160, 200 minus 160 is 40 divided by 200, and sorry for that, 40 divided by 200. And for this case, we have 9 divided by 10 into 100. So this is 90% efficient. This is for approximately 25% efficient, and this is 40% efficient. So the most efficient is the hydroelectric one. So hydroelectric one is the most efficient, and the least efficient is the nuclear one. Yes, so the nuclear one is the least efficient. So nuclear one is the least efficient. So answer C is the right answer. Next question, question number 20. It says that an instruction on a physics book states divide the length between 2 marks on a glass tube into 100 equal parts. What is being described here? Okay, so first, how to calculate weight using extension of a spring. Weight, calculation of weight to extension of a spring. I mean, what's the reason to divide this between 2 marks between on a glass tube into 100 equal parts? So we have seen previously in the same exam or in a question that a spring balance is a device, and that doesn't look, or doesn't use a glass tube, so it doesn't look good. Okay, so keep this in mind. We have some doubts over it. So how to calibrate a thermometer? So thermometer is a glass tube, yes. 100 points. So remember, thermometer goes from X degree Fahrenheit to Y degree Fahrenheit, or say X degree C to Y degree C as well in centigrade. And again, some are from say minus 10 degrees to 120 degrees, sorry, Fahrenheit. Or 10 to minus 10 to say 90 degree Fahrenheit, something like that. And then correspondingly values of degree centigrade are there. So yes, it can be our thing, and it's a glass tube as well. How to measure volume of a measuring cylinder? Yes, measuring cylinder is again in the form of a glass but it's not a tube, it's a sort of a beaker sort of thing. And secondly, it can be of plastic as well. The thermometers are not made of plastics, especially the mercury ones, no. So we have some doubts over this as well. So how to determine pressure in with a manometer? So manometers are a U-shaped tube, again of glass as well. It can be made of other transparent plastics materials as well. So the nearest or the best looking answer for this for me is answer number B. Okay, so I'll go with B. So next question number 21. What is the unit of heat capacity? So remember, heat capacity Q equals to uh, C into delta T. Remember, do not confuse it with specific heat capacity, that is mc theta. Do not confuse it with this. This is specific heat capacity and this is heat capacity. So this is C times delta T. So heat capacity generally is in joules, delta T in degree centigrade. That is my heat capacity, or capital C. Answer is again C, J divided by degree centigrade. And then it says a block of aluminum is heated. So aluminum is a metal and that metal is heated. What happens to the kinetic energy and to the potential energy of the molecules? So block of aluminum, aluminum is a metal, metal is heated. So kinetic energy will increase because heating will increase, or thermal energy will increase the vibration of the atoms of the aluminum. Writing molecules, I don't think it's a good choice of words, but so we can, if it's written as molecules, we can say that the molecules will start vibrating with more energy. So they basically increase the overall kinetic energy. But since aluminum is a metal, what happens by heating? So with metals, when we heat different metals, the electrons residing, so electrons gain energy from their rest states, and they are excited to higher energy states or higher electronic states. And once the electrons are excited to this higher energy state, they basically this excitation it corresponds to increase in potential energy of the individual atoms or the electrons of that atom as well, and that is actually in a way um, so if we have to derive a relationship, so the potential energy gained is actually, because of heating, is approximately 2 times the kinetic energy gained by heating. So yes, both kinetic energy and potential energy for the metal shall increase. So answer will be A. Next question, question number 33. It says, which statement about melting point and boiling point of water is correct? So first part, both processes are accompanied by decrease in volume. Now, one is by decrease in volume, one is increase in volume. Both processes involve energy transfer and temperature change. So energy transfer and temperature change. So during melting of ice and boiling of water. So melting of ice happens at 0 degrees C, and boiling of water 100 degrees C. No temperature change happens. So energy transfer happens, yes. State change happens, means energy transfer is happening, but no temperature change. So no. Both processes involve absorption of latent heat. Yes, both are happening at the same temperature. There is no change in temperatures. That means that there is absorption of latent heat. Yes, so both processes result in increase in intermolecular forces. No. So melting of ice and boiling of ice, the intermolecular forces are not increase in both cases. So, or in a way, actually, the intermolecular forces decrease in both the cases. So answer C is the best choice we have. Next question. It says a substance has a melting point of minus 17 degrees C and a boiling point of 117 degrees C. In which state does the substance exist at minus 10 and minus 100? So it's the easiest ways to, have this charts. This is my melting point, MP. This is minus 17 degrees C. This is my boiling point. This is my 17 degrees C. My substance will be liquid during the here. Gas in this as it moves away from 117, and it will be solid if less than. So my temperatures are minus 10 degrees centigrade and 110 degrees. So 110 degrees C. So it falls in the liquid range. So both cases will be liquid. So liquid here and liquid here. Answer of C will be the best choice. Question number 25, it says a smoke particle Z is seen to move randomly when suspended in air as illustrated. Which statement explains why Z moves randomly? So this is basically the Brownian motion. So Brownian motion, basically, if it's suspended in air, so the air molecules are coming from random directions and hitting Z, and that is why the overall resultant force acting on Z is pretty random. So let's see which statements uh, explains this better. Air molecules are much larger than Z. Air molecules are smaller than Z. No. Air molecules hit Z from different directions. Yes. Air molecules vibrate about fixed position and doesn't, I mean, makes any sense here. So answer C is the best choice we get. So question number 6, it says, oh, sorry, question number 26. The electromagnetic wave has a speed of 3 into 10 to power 10 to power 8 meters per second and a wavelength of 10 centimeter. What is the frequency of the wave? So remember, C equals to F lambda. C is 3 into 10 to power 8. F we have to calculate, lambda is 10. Remember, we have to use meters as our units. So do not forget this. To power 8 multiplied by 100 divided by 10 is the frequency. This 3 into 10 to power 9, or you can say 3 gigahertz. 3 into 10 to power 9. Answer D is the right choice. Question number 27. 3 objects P, Q, and R are placed in front of a plane mirror. The student's eye is in position as shown. The student is at this position. Which of the images P, Q, and R can the student see in the mirror? So P will be somewhere here. Q will be somewhere here. R will be somewhere here. Okay. So the student, this is the eye line for the student. So light rays coming uh, from this direction. Say this student will see Q. Yes, Q will be visible. P will be in the line of sight. R is not in the line of sight and will not be able to see R as a case. So let's see. P, yes, P can be seen. Q can be seen. R cannot be seen. Tick tick cross. Tick tick tick. No. Tick tick cross. Yes. Tick cross cross. No. Cross cross cross. So answer B is the best choice we have. Then question number 28. Question number 28, it says that a ray of light R is incident on water, air surface with an angle of incidence as, so with angle of incidence theta, angle theta is less than the critical angle. That is fine. This statement describes the subsequent path of R. So again, a light is shining on an interface, an interface from basically in a medium that is denser and moving to a rare medium, and it is less than critical angle. It means that it will, or refraction will takes place rather than total internal reflection. So light is moving from denser to rarer medium, so it will move away from the normal. So it will move away from the normal. This will be the light that moves into the air. So this will be my theta refracted. This is my theta incidence. This will be my theta reflected. This is my theta refracted. So the refracted light. So let's see what which statements are good. So it travels back into water with an angle of reflection equal to c. No, the angle of reflection is must be equal to theta I equals to theta r because of the Snell's law. Uh, mm, Not Snell's law. I think it's law of reflection basically. Snell's law is different. So part two, it travels back into the water at angle reflection greater than no, it remains must be this. It travels into air with an angle of refraction. Yes, refraction takes place greater than theta. Yes, theta r is greater than theta I. Yes, travels into the air with smaller than I. No, because it's moving from denser to rarer medium. Light moves from denser to rare medium, and it moves or it refracts away from the normal. So that is how it looks like. So answer number C will be the best choice we get. So next question. In question number 29, it says a parallel beam of light is incident on a thin converging lens. F is the focal point of the lens. So what happens here? So which ray shows the diagram? So let's try to make it. So this ray, uh, so air to glass. So this is air. This is glass. This is again air. So lighter medium to denser medium towards the normal, bends a little bit, bends here, so it moves there, and denser to rare, this is the normal away from the normal, so it moves somewhat here, something like this. Right, ray again, rarer to denser towards the normal, and then away from the normal. So something like this, but if I have to draw it more in a better way, so towards the normal, and then away from the normal. So something like this. So basically, they both converge on this focal plane at one point. You can say something like this. So generally, so light is basically coming from infinity, so it will be it's coming at an angle at this, and that will not be at the focus. If these lines will be parallel to the plane, they would be converging at f. So if it's coming something like this, it would be converging somewhere at below f. So this is, we need a diagram that looks something like this. So something like this, no, because the light rays are coming from infinity. So this is not the best choice. This, no, it will, the image will form on the focal plane. This thing only happens if this ray is coming this way, and this ray is coming this way, and this ray, for example, is coming this way. So this will happen in this manner. Otherwise, no. So this is the most likely image which relates to what we have, or I have drawn over here. So next question. Question 30. Which description of sound wave is correct? A longitudinal electromagnetic wave. Sound wave is only longitudinal wave, not electromagnetic. It says a transverse electromagnetic wave. No, it's simply a longitudinal wave. Oscillations of particles parallel to the direction of the travel of wave energy. Yes. Longitudinal waves, it does the same. Oscillation of particles perpendicular to the direction of the wave. It is for the transverse wave. So answer C is the right choice we have. So next question. It says, where does sound travel fastest? Vacuum, gases, liquid, solids. Sound travel fastest in the solids. It's a fact we have. Then, so in basically in vacuum, sorry, previous question, in vacuum sound doesn't travel. Gases very lowest, fastest in solid, then in liquids, then in gases, and there's no traveling of sound in vacuum. So next question, 32. The bar magnet is placed in a hollow cylindrical iron or a hollow iron cylinder. The diagram shows the magnetic field pattern produced, which is the cause of field inside the cylindrical wall. Electromagnetic generation. So there is no movement of the magnet here. So there is no electromagnetic generation. Again, electromagnetic induction, again the magnet isn't moving, there is no sort of electricity sort of thing here, and we have no electrical connection, no movement of magnetic field in a magnetic material. Electrostatic induction, no, there is no statics involved, no electrostatics involved here. In fact, there is no electricity involved here. So actually what's happening, it's magnetic induction, simply D. This is the best answer, 32. Then question number 33. It says a polythene rod is brought near the stream of water from a metal tap, which is earth. So metal tap is earth. The tap water is an electrical conductor. The water moves towards the rod as shown. Which of the description of the rod and water is correct? Okay, so which description of the rod and water is correct? So what happening here is that our tap is earth and our water following from an earth connections. Technically, there is no charge on the flowing water. So the flowing water is uncharged. So uncharged. So charged cases will be neglected. So since the polythene rod is moved near the stream and the stream is moved towards the rod. So if it moves toward the rod, it means that there are some sort of charges that are associated with the rod, and those charges has induced uh, some charge, and that water basically is pulled towards it. So it means that a charge rod is charged. Uh, Again, charged, two cases will be there. So if there is a rod is uncharged, there won't be any movement. So these two won't be the cases. So answer B is the right choice we have. Sorry. So the rod is charged, and sorry. I think I have made a mistake. Let's try it again. So rod will be charged for sure. So the tap, there is no uh, tap is earth, and the water is falling, flow of water, or it's flowing into the air, and it basically, yes, so it water is actually charged. Water gets charged because of friction here, yes. So water gets some charge because of friction, and then if a polythene rod is brought near to it, then it can either attract or it can either move away. So if say water is negatively charged and rod is positively charged, it will attract towards it, move towards the rod. And both, if its rod is negatively charged and water is negatively charged, it can move away from it. So the water moves towards the rod, it means that both of these materials are charged. So both rod is charged and the water is charged. This is how it happens. So with the earthing of this, basically the tap is not conducting, and since water is falling, and the falling of water charges it because of the friction. So for that, for this case, the best answer is A, for that matter. So rod is charged and the water is charged as well. Next question. Question 34. It says a small negative charge is placed at a point where electric field is vertically upwards. So for example, consider these two parallel plates. And these two parallel plates are in 3 dimension. You can call it, say, X, Y, and Z. So this is, say, a positively charged plate, negative charged plate, and that basically makes the electric field vertically upwards. Electric field is from positive to negative. So this is, for example, we have an electric field. So if a charged particle is here, negatively charged particle, or so a charge due to the field. So this is a charge, or not Q, Q is a charge. So for force is given as Q times E. So the force will be acting, it is vertically upwards, so the force will be acting vertically downwards on this. So this is vertically upwards, so the force on charge will be vertically downwards. Upward, so vertically downwards, B. So B will be the right answer. So force equals to Q charge by electric field. So electric field direction is given. The force will be in a way to oppose the electric field. And if it's vertically upwards, it would be vertically downwards. That would be the best choice for this. So question number 35, it says a circuit shown the resistance of Y is 4 times greater than the resistance of X. What is the difference in Vy and Vx of the voltages as shown? So say this resistance is R and this is resistance is for Y is 4 times greater than R. Okay, so if I have to measure the current I, so I will be V divided by R. So my voltage is 10, R is 5 R, R plus 4R, 5R. So it will be 2 divided by R, that is the current in there. So voltage in X will be I into R. So I is 2 by R multiplied by R. So voltage will be 2 volts. So voltage in Y, again, IR is the formula, resist RX. So resistance RX, see, this is RY. So I is 2 by R, RY is 4R. This is actually 8 volts. So it is asking us to give Vy minus Vx. Simply Vy minus Vx is 8 minus 2 volts. It is 6 volts. So answer is C, 6 volts. Okay, I have just simply used Ohm's law here. So Ohm's law is V equals to IR, and the circuit is in series connection. Remember, series connection. In series, the current remains the same. Current remains the same. Unlike parallel connection where voltage remains the same. So next part, question number 36, it says two identical resistors connected in parallel have a total resistance of 4 ohms. What is the total resistance when the two resistors are connected in series? So resistance, say R, both are connected in parallel, R. So the effective resistance R total is R multiplied by R divided by R plus R. This is 2R, this is R squared divided by 2R, and this is R by 2. And this R total is equal to 4. So it means that R individual is equal to 8 ohms. So in series, if I have to add, so series resistance R, R total series will be R plus R. This will be 2R, so 16 ohms. D is the answer. So remember, in parallel, R total in parallel can be calculated by RT parallel is equal to 1 by R plus 1 by R. So if RTP have to calculate, it will be R multiplied by R divided by R plus R. So this is basically the formula I used here. So this is how it's done. So next question number 37, it says 3 identical lamps and 3 ammeters are connected as shown. The readings on ammeter 1, 2, and 3, how the readings are related. Okay. So what is happening? So ammeter, so this ammeter is measuring the current that is passing through this. So basically, this lamp will have a resistance R, this lamp will have a resistance R, this lamp will have a resistance R. So what is happening? So we have a circuit in which two lamps with R and 2R are connected in parallel with a voltage source, right? So the current I is flowing. So the current I is flowing here, and it comes and it divides into two paths. One is this, one is this. So this is a low resistance path. It means that more current will pass here, less current will pass here. So I2 will be greater than I3. And what about I1? So I1 is the actual or the total current that is flowing in the circuit. So basically I1 comes to this point, and at this point it divides into two regions. Similarly, I2 goes here, I3 comes from here, and again I1 is this. So I1 is basically the sum of I2 plus I3. So technically I1 is equal to I2 plus I3. This is also the Kirchhoff law. And so we can simply say that I1 is greater than both I2 and I3. So we can just simply write that I1 greater than I2 greater than I3. These will be the readings on the uh, ammeters. So I1, I2, I3. Okay. Then question number 38. It says a thermistor and a light dependent resistor are connected in series. The potential difference PD of 6 volt is applied across them as shown. Okay, so 6 volt is the potential difference across there. The thermistor has a resistance of 600 ohms. So we have a cold room and we have a warm room. So thermistor resistance is 6000 ohms in a cold room and 1000 ohms in a warm room. And an LDR has a resistance of 2000 ohms in cold room and 500 ohms in bright light. So this is dim light. This is bright light. Okay. So the thing is, the thermistor has a resistance of, so when is the potential difference across LDR light dependent resistor as 2 volts? Okay. So since these two are connected in series, the potential resistance will drop across them as per their uh, amount of resistance. So what would be the case? Say, so 6 volts are here. So if so, there will be these combination of these resistances. Say, I would say my thermistor is or another way, if I have to say 2 volts are dropping here, 4 volts must be dropping here. So again, I would remain the same in the circuit, and voltage will be equal to I into R of this device. So again, this will be R of this device. So technically, if I have to write the formula, V equals to I R, and R is basically R thermistor plus R LDR. This will be my resistance. So voltage is, let's say, call my voltage as 6 volts. 6 volt is divided by R T plus R LDR is equal to my actual current that flows through the uh, both of these devices. So now I have to select a combination of RT and RLDR that gives me a voltage across LDR. So V LDR is equal to I multiplied by R LDR. This is 2 volts divided by R LDR, and this is equal, I is equal to 6 divided by R T plus R LDR. So let's solve this. 2 multiplied by RT plus R LDR into 6 times R of LDR. So 2 RT equals to 6 R LDR minus 2 R LDR. So this becomes 2 RT, 4 R LDR. So RT is equivalent to twice the value of R LDR if we have to get. So RT, so if RT is 100, then LDR must be 2 times, sorry, um, 2 times LDR. So if R, sorry, so this value R thermistor must be equal to twice whatever the value of R of LDR is there. So if my LDR is 500, this thermistor must be 1000. Yes. So if LDR is 2000, this must be 4000. So this is not the case. So it means that bright light and warm room will be my best choice of conditions in order to have this 2-volt condition working. So cold room, no; cold room, no; warm room, yes; and bright light, yes. So answer C will be my correct answer. So next question, question number 39. It says a student calculates the amount of energy used by an electric heater. What is the equation of for calculating the energy E in kilowatt hours? So remember kilowatt hours. So this is something. So kilo is basically um, so just before that, let's try to see uh, these values. So amperes, voltage. Remember, power equals to VI, amperes into voltage, or I into yes. So and this is given as watts. So ampere volts is watts. So this is watts. This is watts. Again, this is equivalent to watt. This is equivalent to watt, right? And this is multi-time in seconds. So this is watt seconds. Now this is not the answer. So this is time in hours. So watt hours. So this is watt hours. This is not kilowatt hours. Okay. So this is time in seconds. So this is watt hour. Watt hour seconds. No, sorry. Watt seconds divided by 1000. So again, this is not the or you can say that this is kilowatt seconds basically. So E again, watt time hours divided by 1000. So it is basically kilowatt hours. So this answer D will be my preference or choice for this case. So question number 40, or the last question of this exam. Again, it says an isotope P is radioactive and a half-life of 7 years. So capital T is 7 years. Initially contains, so P initial weight is 0.16 kg of P. How long the sample contain this? So final weight is 0.002 kg, and we have to find out how long it takes. So P final, remember, is Pi half times the time it takes divided by the half-life, TH half-life. So P final is 0.002, Pi is 0.016, half, I have to calculate this T divided by 7 years. So just simply equate the two fractions together, 0.016, 1 by 2, T by 7. So this whole thing becomes 1 by 2 power 3 equals to 1 by 2 T divided by capital T. Uh, so this is basically 7. So it is 20. So comparing the fractions of 3 into T half-life equals to T. 3 into 7 is 21 years. This is equal to T. So anything 21 is A, no, B, no, C, yes. So 21 years, part C will be my right answer. So this is uh, paper number 1 for 2020 session, October, November, version number 1. I hope you would have enjoyed this session. And if you have any questions, please use the chat box available. And I wish you best of luck for your exams and for your future endeavors. Thank you very much.